Greetings, Patriots. In today's lesson, what you're going to do is we're going to look and identify functions in a set of ordered pairs or tables only. So please make sure you look at your guided notes and set up your notebook accordingly. Here's one way that you could do that. Our objective is I will identify the functions or not a function in a set of ordered pairs or a table. So if I'm given an ordered pair or table, I'm going to be able to identify whether or not I have a function. I will also write the domain values and the range values. So let's go ahead and look at these problems under I do. I have given you a set of ordered pairs here. So one thing, as I've mentioned before in previous videos, go and take a pink highlighter and highlight all your X values. That's always helpful when you highlight your X values so you know that that's your focus. You know, we always, our function definition says every X has to be paired with only one Y value. The characteristics is if I take a look at just my domain values, what's nice here is I see they're all different. So my input values or my X values, right, are as follows. I don't have to write any duplicates. I can set them up. So -2, -1, 0, 1, and 2. All of these are my input values, right? My range values are always highlighted in yellow. So I can see I have 3, 4, 6, 5, and 4 repeated. And that's okay. Remember to get rid of any duplicates. You don't necessarily need them. So my range values will consist of 3. I like to put them in order, increasing order. From 3 to 4, I don't need to repeat the 4 again. 5 and 6. And so it's okay that a domain has a common Y value as long as it's not assigned two different values. So function or not a function is what we need to identify. So when I look at the following, I know that this is definitely an example of a function because it meets, right? Again, y, my range values, my y values here are a function of x. Okay? Every element in the domain is paired with one y value, and that's the key. Only one y value in the range. So this is a function because every element in the domain is paired with one y value. Okay? All right, let's go ahead and take a look at our example number 2. Once again, with your pink highlighters, highlight all your X values. Here, I've given you another list of ordered pairs. And as you can see, in my domain, I have 5 ordered pairs. Well, 4 is repeated twice. I'm not going to go ahead and write that. 5 is also repeated twice. And 6. These are all of my X values that belong a part of my domain. In my range values, I see that I have 12, 15, 18, 21, and 24. Each one of those is different. So my range values, I don't have any repeaters there. 12, 15, 18, 21, and 24. So this is my notation for my range. However, according to the definition, right, 4 has been assigned a 12, an output value of 12 and 15. And my function definition says that my X values can only be assigned or paired with one Y value. So therefore, this is not a function. Why? Because the X value of 4 and 5 actually, right? And I'm just going to use one of them in my justification. But the X value of 4 messes it up. As I tell you in class, it's cheating. It has 2 girlfriends or 2 boyfriends. It is paired. It may be a relationship, but it's not going to function, right? It is paired with 12 and 15. So therefore, this makes this relationship not a function. Okay, and that's what you need to remember. It's not a function because of the 4, but also because 5 has been paired with 18 and 21. So you got to go back to that definition, and sometimes highlighting helps you as well. Let's go ahead now and take a look at my relations, but in a table, okay, or an input-output table as you know it. Once again, start by highlighting. Our focus is our x values, okay? That's the only thing I'm concerned about. So I look at my input values or my x values, -2, 0, 1, and 2. What's an awesome indicator here is that I don't have any repeating x values, which lets me to believe that every x is assigned. So here's my domain. Every x element in the input values or in the domain values has been assigned only one time. -2, 0, 1, and 2. Every x is different. There's no duplicates. That's a great sign. They have all been assigned the range of 3, which is fine. They can have a common y value. Since each one of these is different, and I'm just going to kind of give you an idea of a map. Since each one of them is different, they have been assigned only one y value, and that is okay. So I can say that yes, this is a function. Okay? Each value, and I'm gonna give myself some room here, but each value in the domain, referring to all my x values, are assigned, oops, all right, sometimes it's hard to write here, are assigned to one element in the range, and that is okay. That can happen. Okay, so each value in the domain are assigned to one element in the range. So sharing, I want you to understand that I accidentally stopped my recording. Sharing a common y value is okay. Sharing a common y value is okay, and in the range, okay, is okay. So, because every x is different, it still meets the definition. Every x is paired with only one y value. So each value in the domain are assigned to one element in the range. This is a function. Let's go ahead and go to our last example here. Highlight your x values, -2, 0, 6, 4, and 6. Uh-oh, I see a repeater. Let me go check out my repeater. Okay, if my repeater is assigned two different values, oh, in this case it is, I don't think I'm going to have a function here. I can already tell. All right, so again, putting these in order in my domain, my set of all my x values are -2, 0, 4, and 6. I'm not going to write the 6 twice. Okay, now I'm going to go and look at my y values. 0, -3, 8, -1, -8. That is fine. My range values, again, I'm going to write them in increasing order. -8 is the smallest. -3 is next. -1, 0, and +8. Okay? So if I look at that, I actually have 5 y values. So therefore, 6 has been assigned twice. So this is not a function. So I have to say this relation is not a function. And that's what I'm going to say. It's a relation, but it's not a function. It's not that special function. This relation is not a function. And why is it not a function? Because of that element of 6. Okay? The element or the input value, right? the x-coordinate, whichever you want to call it, you've heard me call it multiple ways. The x-coordinate, right, 6, is paired with more than one y-coordinate. Is paired with an 8 and a -8. So therefore, it's paired with more than one y value. And according to the definition, it can only be assigned one y value. So the x-coordinate of 6 is paired with 8 and -8. So therefore, this relation is not a function. So now what I'd like you to do is take the opportunity to work on problem 5 and problem 6. You will do the same thing. You will go through, highlight your x-coordinates, and I want you to look closely, write your domain, write your range, and identify whether or not the set of ordered pairs in the table, do they represent a function or not a function? Highlight your y values. Do the same thing for your number 6. Highlight your x values. Remember, we don't want any duplicates in our x coordinates, okay? So highlight them, write your domain, and write your range, and then identify whether or not you have a function. I will let you work on this, and then tomorrow we will talk about it in class. Have a great day, Patriots.